That is a small but smart linear actuator. What is it used for?
So as you can see here, it was initially developed to replace the vacuum actuators, which we can find on the ICEs. But more generally speaking, we develop an actuator which is withstanding in harsh environments. And by harsh environments, I mean environments which is subject to high temperatures, high vibrations, and which requires very long durability.
And now it's a very compact actuator, in fact. What are the main values which you can offer with that product?
Indeed, Max. So as you can see, it's here very small, very compact. It's also very lightweight. And despite the size, it has a very high force. So high power density up to 85 newtons. And of course, as I just mentioned, high durability in the engine compartment. On top of this, you mentioned the smart actuator. It has embedded electronics.
So how does the integrated electronics enhance the performance and the reliability of the product?
So having these electronics allows us to have several features. Basically, we'll have diagnostics features. So for example, we'll be able to detect a failure on the system on which is connected. Then we'll be able to have some predictive maintenance. Due to the analysis of the data, we'll be able also to detect some wear on the system. For example, if there's anything blocked inside it. And in the end, also to perform some safety features. For example, fail-safe protection. When we notice through the actuator that there is anything going wrong with the system, for example, a higher temperature or a blocking point which cannot be unblocked, we will then alert the vehicle and the ECU to inform the driver that he must stop.
Looking at those two types of actuators, I see there are differences. How can that product be customized based on the customer needs and the specific applications?
So if we have a look at the two versions of the actuators, they have the same core, but with several differences. For example, here we can change the interfaces by the mounting ears or the moving part here, the pintle design that can be also designed according to the wishes of the customer. And also on the back here, we can have different type of connectors which can be oriented 90 degrees or straight lines.
What are the targeted markets you are currently looking at for use of these linear actuators?
So currently we are in SOP for engine management applications, for thermal management applications, and also for air induction. We can easily imagine that this type of actuators can be used for plenty of other applications due to its very easy integration capabilities and all the smart features which are inside this actuator.
Thank you.
You're welcome.